All right, so today's lesson is about chord secant intersection. So a chord is when a line goes from one point to another point inside the circle. So from here to here is one C chord. So from this point here to this point here is a chord. From this point here to this point here is another chord, right? Now, a secant, which we will cover in the next lesson, but just to let you know, a secant is when the line continues all the way through the circle and outside. So if this line here were to continue this way and that way, it becomes a secant. So a chord is kind of like part of a secant, but the chord is the part that's inside the circle. So from here to here is a chord. So here we have two chords. So the gears here says when two chords cross each other inside a circle, the products, or when you multiply the answer to a multiplication problem of their segments, are equal. So each chord has two segments. There's this segment here and this segment here. So when they cross, they create a point. And it creates four segments. On this chord, it creates segment here and segment there. On this chord, it creates a segment here and a segment there. So let me name the segments. So let's start with this segment first. I'm sorry, with this chord. And I'm going to name the segments. So from here to here, I'm going to name A. From here to here, I'm going to name A. From here to here, I'm going to name B. All right? So we took care of one chord. Let's do this chord now. This segment from here to here is called C. And then this segment from here to here is called D. Okay? Now, it says when two chords cross each other inside a circle, the products of their segments are equal. So that means that when you multiply the two segments of the same chord and you equal it to the two segments of the other chord, then you get an equal balance. They are equal to each other. So let's say that I say this chord here is my purple chord. So this segment here from here to here is A, and from here to here is B. So that's my purple. Then I'm going to call this chord here pink. So from here to here is pink. So that means that from here to the center, or not from the center, from here to this point is C. And from this point to that point is D. So what ends up happening is that when you multiply, right, when you multiply pink times pink, it's going to equal purple times purple. So if we say pink times pink is equal to purple times purple. So pink times pink is equal to purple times purple. So pink times pink is C times D is equal to purple times purple, A times B. A times B. Now, let's say that we assign numbers to these A, B, C, and D, right? So let's say that I say from here to here, A is equal to 5. Right? And from here to here, I say is 25. Right? And then I say C here, let's say from here to here is 15. Right? And then D is, I don't know. I have no idea what D is. So let's fill in our information here and see what we get. So C is 15. I'll put it in parentheses. D, I don't know what D is, so I'm going to leave it as D. Draw my line of separation here. A is 5 times B is 25. Right? So, what do? What do you guys think? Well, multiply here. Let's multiply these two here. And that gives us 125. Move this up a little bit. 15 times D is 15D. Well, how do we solve for D here? How do we get D by itself? We cross out 15 and we divide by 15. And we get D is equal to 8.3. So we found out how much D is. So say from here to here is 8.3 inches, centimeters, yards, feet, whatever it is that the problem is asking for, right? This case, it was units because there was no specific measurement. So it's just considered units. All right. So that's the idea for chords, intersection inside the circle. They crossed inside the circle. So let's see a couple of examples of what you're going to see on Delta Math. So here. So it's going to say solve for x, right? So I see two chords there. I see one chord from here to here and another chord from here to here. So I'm going to call this chord my pink chord. So pink to pink. And I'm going to call this chord my purple chord. Purple to purple. So I know this is my purple and this is my purple. And this is my pink and this is my pink. Now I have to remember that pink times pink is equal to purple times purple. So, right? Pink times pink is equal to purple times purple. So let's fill that in. So let's see. What are the two pinks? 12 and x. So we say 12 times x, right? Parentheses means times. The little dot means times as well, right? Is equal to purple times purple, 20 times 3. 20 times 3, right? So we draw our line of separation here. 12 times x is 12x. Right? These two give me 12x. 20 times 3 gives me 60. Well, I want to get x by itself because I want to solve for x. So this means 12 times x, so I cross out 12 and I divide by 12. 60 divided by 12 is equal to 5. And there we go. Look at that. X is equal to 5. Perfect. Perfect, perfect, perfect. Remember, do your example with me. Draw your own circle on your own paper. Draw your chords. Put in your numbers, right? Okay. Next, this example right here. So this time I'm going to make this chord pink. So pink to pink. So I know that is my pink and that is my pink. And I'm going to say purple. To purple is my second chord, and 10 and 8. So since this is equal, this is balanced. When this is balanced, that means that I can change the sides of these and it's the same. So instead of writing pink first, I'm going to write purple times purple is equal to pink times pink. Right? So I'm going to do my purples first, right, on this one. So I'm going to say, this time I'm going to do parentheses. 10 times 8 is equal to pink times pink, 4 times x. Draw my line of separation. Now see here I did parentheses. On the top example I did points, right? All the same, it means multiplication. So these two I get 10 times 8 is 80. 4 times x is 4x. Now I want to solve for x here. My goal is to get x by itself here. So this means 4 times x. So the inverse of multiplying by 4 is dividing by 4. 80 divided by 4 is 20. So my x is equal to 20. And there you go. Right? And these are the kinds of examples you're going to find when you're going to solve for chords / secants intersection inside the circle, and you're going to find the missing segment. Solve for x.